Sure.
All right, guys, so there's the general equation of a circle, right? It could look like this, of course, but it's sort of like solving for y in a line, putting a parabola in standard form. If you do those things, you see certain aspects of the graph that are important. So if I take this and put it in that form, I can see the center and the radius. So if the center is 3, 2, what exactly does that mean? 3 goes where? Goes in for h because it's the x piece. So it's going to affect the x piece. So that'll be x minus 3 square plus y. Good, minus 2 square equals 16. Beautiful. Everybody always freaks out about that square. You either square root too much or you don't square or something. If r is 4, then r squared is 16. Yes. All right. I'm almost certain that if you started this, you're not quite done with it yet. If you haven't started it, then do that. John. You got your other stuff, right? I gave it this morning, didn't I? No?
No.
You're...
I'm today. After.
No, you're... Carlos, okay.
Yeah. Oh, I thought you were talking about that.
Sure. Here. Sorry, Joaquin. There's that stuff. Joaquin. There's the one for today. The one for yesterday's down in there. Sure. Alright. So I like to look at completing a square is just collecting all my x terms, getting them all into one big term. They're all running amok. I love that. So if you put these together, x squared plus 4x, leave some room. Get your y squared stuff, your y stuff together, leave some room. Add the 3 over, get that sucker out the way. Now I've got it set up to complete the square. What do I have to put here? 2. 4. So plus 4. Half of 4 is 2 squared is 4. So it's going to factor as x plus 2 squared. The minute I put plus 4 there, I better put it over here. I'm going to run in my graph. Oh, scheisse. Scheisse. That's going to go left here. We'll see what happens. What about what goes here? 9. Half the negative 6. Negative 3 squared is 9. So that's going to factor like this. And if I put a 9 there, I better put a 9 over there. So overall I get 16. I like it. And then what's the center? Yeah, negative 2 and 3. Good. Remember, when you put that, don't really put a point there. And the radius is going to be what? Philip, right?
Yeah.
Oh, wait a minute. All right. This one's in there. You need this one. Oh, put this over here.
Edward.
Edward. Oh my gosh. I need one of those too. Okay. Alright. So center is negative 2, 3. Radius is 4. So negative 2, 3. Put a little C for the center. And from there I'm going to count out 4. It's crazy. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yay. 1, 2, 3, 4. And like always, you can check those points. If you plug one of those points in, it's got to make it a true statement. Otherwise, you've done something horribly wrong. Oh, crap. Oh, Chase Bay, always Charlie Brown. Don't do that. Not a point, not a point. Oh, now he's dead. Oh, I'm sorry, Charlie. Charlie's dead. Sorry. Jeff laughing over dead comments for characters. Oh. Okay, so I mean that's all there is to circles. They're kind of remarkably nice, to be honest. And I kind of gave us a little bit of a preview for ellipses. Let me see if you guys can handle this. You guys see the formula for an ellipse? Try to plug A in for X and solve for Y. Try to plug A, yeah, you need that, hold on. You need this to, try to plug A in for X and solve for Y, because I'm crazy. I love you guys. And you're like, that's too many freaking letters. Too bad. Try to plug an A in for X and then solve. So, don't worry, I'm going to bring some numbers in just to make this more apparent. If I plug an A in for X, this becomes A squared over A squared plus Y squared over B squared equals 1. Right? I get 1 plus Y squared over B squared equals 1. Is that cool? Subtract 1, subtract 1. I get Y squared over B squared equals 0. What's the only way that could happen? Is if Y is... Yeah. So that's where A0 comes from. And the same thing would happen if I plug in negative A in. You guys see that? Why can all right? Let's look at a concrete example of this, and notice how far do I go out on the x-axis? A, and where are the A's? Under the x's. Holy shit! So whatever letter they're with, it's related to how far you go out on that axis, right? So if I had, for example, x squared over 16 plus y squared over 4 equals 1. Let's talk about this a little bit. Why can x not be why can't x be bigger than 4? I love this question. Would you free? If I try to put x bigger than 4, pick a number bigger than 4. 5. If I try to plug that in, what happens? 5 squared over 16 plus y squared over 4 equals 1. 5 squared over 16 is bigger than 1. And I'm adding a positive number to it. Is there any way to make this equation true? If I have a number bigger than 1, can I add something positive to it and make it become 1? If I have a number bigger than 1, the only way to make it become 1 is to subtract something away from it. So that's why these numbers set up what's the extremes for x. X can go up to 4 and down to negative 4. Y can go up to what and down to what? 2. Y can go up to 2 and down to negative 2. Because y squared could be 4, so y can go up to 2 and down to negative 2. This way. So it's almost too nice to believe. And let me show you the connection between this and circles. The difference between this and a circle equation would be something like x squared plus y squared equals 16. Cool? How do I know that's a circle? It's in the right form, for one thing. These are both over 1. They're both over coefficient. They're all the same coefficients. There's nothing different about the x and y piece. So it goes the same amount in both directions. If I divide by 16, don't I make it look like the ellipse equation? X squared over 16 plus y squared over 16 equals 1. That looks like the ellipse equation. But in this case, how far out would I go on the x? 4. How far out would I go on the y? 4. See, so that's not an ellipse. A circle is just a special ellipse. Circle is just an ellipse where you go the same amount out on the x and the y. So it comes out perfectly symmetric in all directions. Ellipses, no, you go out different amounts. They're not perfectly symmetric everywhere. Only a couple places. Okay. Alright, so that's me talking about concept shit again. I know, let me bring it back to nuts and bolts, what you actually have to be able to do. For this problem. First off, how do I know that the center is 0, 0? Ellipses still have a center. How do I know the center is 0, 0? Let me do it this way. Would the center be 0, 0 here? How do you know? Because it's been shifted. Has this been shifted? No. So the center is 0, 0. So that's where I count from. I start counting from 0, 0. How far out on the x-axis do I go? How far on the y-axis do I go? 7. So that's let that be unbelievably nice. Let that just be so freaking nice. You start at 0, 0 because that's the center. On the x, you go 4 because that's the number that's with the x. 1, 4. 1, 4. On the y, I'm going to go 7. 1, 4, 5, 6. Oh, it says it's 7. Whoa. Bless you. And then I'm going to just connect those. And thankfully, ellipses, all my circles look like ellipses already. So this is Stewie laying down in bed. Okay. This is a UFO diving into the ocean, as they do sometimes. Oh. I got it. Oh. Okay, grab one of those. And nope. Give it too much. Mike. Now, guys, what's wrong with this equation here? What's wrong with the form of it? It's not over anything, but the more important thing, it doesn't actually have to be over anything at first, to be honest. We're not going to look at one of those yet. The most important thing about this form is that this side is 1. That's what's really wrong with it. So how do I correct that? I just divide by 100. Divide by 100. Okay, do that and then try to graph it. Get it in the right form, and then identify what you know, and then graph it.
Can we just square root the whole thing?
Say again?
Can you square root the whole thing?
Square root. No.
Just to remind you guys, I can let it go a little bit more here, but when my Math 180 students believe that this is true, it makes me sad. No, that's not true. Right? Radicals are powers, right? And powers do not distribute across addition or subtraction. I like it. So square rooting, yeah, you can. It's not going to do shit for you. You can't square root each piece. That's not allowed. Square roots don't distribute. So don't get too excited, because then everything would be a line. That would suck. Be sure to reduce that so you can see what you're really working with, right? How far out on the x do I go? 5. And of course, this is centered at 0, 0. Plus. So it's important to know where the center is because that's where you start, just like a circle. So 0, 0, so I'm going to go 5 on the x, up 5, down 5. And the y, I'm going to go 2, up 2, down 2. And then I just connected. Oh, shucks, screw it up. I'm going to pretend like I'm an artist. Something else I want to introduce here is, well, let me see, I won't introduce it yet. Let's do this one first. This works the exact same way. You just find the center first and then start counting, just like circles. You're just counting in a different amount in the x and the y direction. So do number 3. Little square is watching you, so what's up with those squares?
I arrived late,
Oh.
so I can't sound it. I don't have the basic.
Read the first side. Read through the first side. Turn it over.
So the center is what?
5, -1.
5, -1. So I'm going to put a little, put a little C down there. 5, -1. And then on the x-axis, I go how far? 2. Now in this case, not x-axis because I'm off the x, but the x direction, right? Parallel to the x-axis. So I go 1, 2, 1, 2. And then in the y direction, I go 5. 1, 2, 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Cool. There's my little shifted ellipse. Make that big. Yay. I like it. Alright. Is that decent? I mean, that's find the center. So you can see how far out it goes. And then go out that far from the center. It's crazy. So do number 4.
Just print it out.
really, the very first thing you always check on these problems is it in the right format? And what tells you that is this side 1? And if it ain't, you just make it 1. Because x squared over 36 plus, what happens here? 9 equals 1. So what's the center? Good. 0, 3. So 0, 3, there's the center. Right there. And then in the x direction, I'm going to go 6. So 1, 6. What did I write? And then the y direction, I'm going to go 3. 1, 2, 3. 1, 2, 3. Then there's we oh shit. And there's we No. What point is this? 0, 0. So if I plug that in, it should do what? It's a point, Jeff, that I'm doing it. If I plug that point into the equation, it will make it true. So 0 plus 4 times 0 minus 3 squared. Negative 3 squared is 9 times 4 is 36. Holy shit! Yay! I mean, so you can always check real quick. Pick a point, check it. I like it. Now, let's talk about, let's take it up to the next level. Okay. Yeah, let's do ax squared. Let's see. Yeah. Plus 50y squared equals 2. So the very first thing, yeah, divide by 2. All right, now, oh my God, I made this one so gross. Yet you sound excited about this. What's wrong with this? I got it equal to 1. It's not over anything. Now here's where some of you guys are going to freak the shit out. Multiplying by 4 is the same thing as dividing by 1/4. Oh yeah, I see. You guys are so much to be excited about. What the shit did I just do? Why the hell is there freaking fractions here? Holy freak. You guys understand? Well, what is x squared divided by 1/4? Isn't that x squared times 4? Same stupid thing. So if you do this side, make it 1, and you actually end up with one or both pieces with nothing underneath, and there's a stupid number here where it's not supposed to be, you got to make it a fraction on the bottom. You have to. So where's the center? That part is nice. Center 0, 0. But then, how far on the x do I go? X direction, I'll go 1/2. Right? Square root of this. Y direction, I go how far? 1/5. I love it. This is what you guys, I desperately want you to understand. I understand your gut reaction to fractions. I do. I understand it. I don't agree with it, but I understand it. But the process doesn't give a shit. How do I figure out how far it goes? I take whatever's underneath and square root it. That's how far it goes in that direction, whichever variable I'm looking at. And it doesn't care what's under there. Same process. So to be smart about this kind of problem, what do is I would pick a really good scale. I'm not going to pick a scale of 1, 2, 3. That would so desperately suck, especially for 1 freaking fifth. So on the x-axis, what would be a really good scale to use? You do it. What do you think? On the x-axis, I've got to go 1/2 of a step up and down. So maybe I'll use a scale of 1/2. You guys understand? You could pick your scale as long as it's consistent on each axis. You could pick your scale to be whatever the shit you want it to be. So instead of 1, 2, 3, which is the basic we always pick by 1, I'm not going to go by 1. I've got to take half freaking steps. Let me go by 1/2. This would be 1. Good. This would be -1/2. -1. Now on the y-axis, it does not have to be the same as the x-axis. And for some reason, students think that they have to be the same, but that's crazy. You've seen, like, in the year 2007, there were 50 of these things sold. 2007, 50. I don't think those scales are the same, right? You don't need them to be, you need them to be the same on that axis. You can't go 2, 4, 38, 61. No. So on the y-axis, remarkably enough, I'm going to go a scale of what? 1/5. Right? It feels a little bit like cheating, but hey. So I'm going to go 1/5, 2/5. Red fish, blue fish. 1/5, 2/5. So now the center is 0, 0. I go 1/2, 1/2, 1/5, 1/5. Yay! Look at that fat little thing. Little pig. So just in case you hit something like that, you can pick your scale to be nice with the numbers you have to work with. All right. One last thing, I think, and then we'll actually, it's always dangerous when I do this, because you guys tend to congregate in the tech ball, and they're still scared of the noise over there. But, oh well, yeah. Obviously, we should be ready for the fact that they're going to give me stuff like this. Oh, let me think about it. Sure. Now, of course, Jeff, crazy. Let me do this. Actually, this is perfect. I was going to do this anyway. Versus this here. Pretend like I did that on purpose. Can you tell me, if I graph this, what would it look like? If I graph this, what would it look like? What's the key difference between a circle and an ellipse? The coefficients of the x squared and y squared for an ellipse have to be, do what you could do. We dealt with this yesterday, we've seen it today. If the coefficients of the x squared and y squared are different, you get an ellipse. So on the first one, are they different? So this would be a circle because it's symmetric. It doesn't care, bless you. X, Y direction, they both have the same coefficient. It's going to go the same amount out in each direction. This one, yeah, coefficients are different. So this would be an, I give it away with that. Oh well, it'd be an ellipse. Do you guys see that? I could very well give you a problem where I say don't graph these. Just tell me what they would look like. And I could throw this one into the mix too. Well, yeah, Jeff, you can do a lot of weird shit. What would that look like? Nope. Why are these ellipses or circles? Because I have an x squared and a y squared, x squared and a y squared. They got to be an ellipse or a circle. Here I've only got, I only have y squared, and then the other one's just x. So what kind of a shape would this be? It'd be a parabola. Parabola. Just because we start talking about something else doesn't mean the other shapes cease to exist. This would be a parabola because they're not both square. In fact, what kind of parabola? Sideways. I like it because it's x and y squared. Now the one that's a little bit harder to tell maybe is which way would it open? Left or right? If you solve for x, you get x equals negative 7y squared. So it's going to open left. The y squared piece has a negative coefficient. It's going to open backwards. It's going to open left. Okay. So keep it true to my promise. We'll leave quite a bit early. That's all right. I have 13.2 homework is up on my math lab. You guys can get started on that over the weekend. I'll see some of you guys in a few in the lab.